Hello, welcome to Chapter 1, Lesson 1. Today we're going to be talking about factors and multiples. So to start off, we're going to talk about greatest common factor, which if we use, the context clues, greatest means the biggest, common means shared, and factor are numbers that multiply together to give us our product. So then we're also going to look at least common multiple. Now, these two things often get mixed up because kids forget the difference between factors and multiples. So multiples are our count by numbers. And then factors, factor multiplied by a factor equals the product. So if we can just remember the difference between factor and multiple, then these aren't too tricky to remember. Let's take a look a little bit deeper here. So GCF stands for greatest common factor. That says, define what does greatest mean? Well, it's kind of the biggest. Common, I like to use the word shared. What do they share? And a factor is a number multiplied by another number. I don't know, we'll just go with that. A number multiplied by another number. LCM stands for least common multiple. Least, smallest. Common, shared. Multiple is our count by numbers. So if I said, what are multiples of 3? You'd count by 3s. 3, 6, 9, 12, and so on. Okay, so if I wanted to find the greatest common factor, you can use common factors or prime factors to find the GCF. So prime factors, a prime number is a whole number that has exactly two factors, 1 and itself. Okay, so if I look here, the question says, there are 1 slice servings of 3 types of cake on a table. Each row has an equal number of servings and only 1 type of cake. What is the greatest number of servings in each row? So if I'm looking at our numbers 10, 15, and 20, and I say, what are the greatest common factors? Okay, so if I look at them, and if I were to use the list method, I would just list all their factors. How do I get to 10? Does 1 go in? Does 2 go in? Does 3? No. 4? No. 5, yes. And then 10 itself. List the factors for 15. 1 times 15, 3 times 5. 20 would be 1 times 20, 2 times 10, 4 times 5, and so on. So they share, their common factors are 1 and 5. Okay, so if I'm looking at the greatest one, I would choose 5. So our greatest common factor for 10, 15, and 20 is 5. So we would say our GCF is equal to 5. How do I know that? Because I listed out the factors. Now the problem with listing factors is you might forget some, right? And so we do have another strategy we can use to make sure we don't forget some. But let's look at A here. Oh, that's what this is supposed to be for. So we would just say our GCF is 5. Lana earned $49 on Friday, $42 on Saturday, and $21 on Sunday selling bracelets. She sold each bracelet for the same amount. What is the most she could have charged for each bracelet? Okay, so let's see. What are our factors for 49? 1, 2, no, 3, no. I know 7 and 49. 7 times 7, right? 42, our GC, or our factors are 1, 2, 2 goes in there, 3, Does 3 go in there? Yeah. 4. Nope. 5. Nope. 6. Yes. 7. Yep. 6 and 7. Yep. 8. Nope. 9. Nope. 10. Nope. I'm going with 42 next. And then if we look at 21, our factors, 1, 2, no, 3 times 7, and 21. Now look, our factors, they share 1, and they all share a factor of 7. So what is the greatest amount she could have charged for each bracelet? $7. There we go. Okay. Find the greatest common factor of 12 and 18. Now here's the deal. Instead of listing, like I said, you can forget numbers. Right? Like 42, I know there's a lot of factors for 42, and I might forget one because I didn't think about it. So if we use prime factorization to solve for our greatest common factor, that's really going to help us out because then we don't have to worry about forgetting anything. So if I wanted to find the greatest common factor of 12 and 18, I could say, well, I know 6 times 2 is 12. Break up 6 into 3 and 2. Bring down the 2. So my prime factors of 12 are 2 times 2 times 3. Okay, so for 18, if I split that up, I could do 9 and 2. Bring down my 2. That's prime. 9 is 3 and 3. So I'd have 3 times 3 times 2. So if I'm looking at what are the factors that they share, they both have a 3. So I'm going to cross off 1, 3 and write it down. They both share a 2. Okay, they don't share anything else, so 3 times 2 or 6 is going to be my GCF. Okay, so let's try doing that for these. So for 12, B12, I can do 3 and 4. 3 is prime. 4 breaks down into 2 times 2. And 66. I can do, well, 6 times 11. 11's prime. 6 is 2 and 3. Those are both prime. So they both share a 2. And they both share a 3. So our greatest common factor for B, our GCF, is equal to 6. Let's do 18 and 30. 18, I'm going to do 6 times 3. 3 is prime. 6, 2 times 3. Okay, then 30, I can do 6 times 5. 5 is prime. 2 times 3 for this. What do they share? They both share 2. Write down a 2. They both share 3. Write down a 3. Oh, look at that. Our GCF for letter C is also 6. Because we've got a 3 and a 5 left over, they don't share those. So I'm going to stop there. You guys can try, pause the video, do D on your own, and see what you get for that one. Oops. All right, lastly, let's look at least common multiple. So if I'm going to look at multiples, they said you can use a number line. Like let's say I wanted to find the least common multiple of 2 and 3. So if red is counting by 2s and blue is counting by 3s, 3, 6, 9, 12, the least, smallest common multiple then would be 6. That's where they both line up. Now, if you're trying to find least common multiple of bigger numbers, this would be a pain. So you could use the list method where you write out all the multiples. But again, that can be a pain because you're going to have to keep going, and some of them might not share least common multiple until you're in the hundreds. So lastly, let's look at the least common multiple using prime factorization. Okay, so if I wanted to know least common multiple of 14 and 21, I'd say, well, 14 is 7 times 2. 21 is 7 times 3. Okay, so if I'm going to look, I'd say, hey, look, they both share a 7, just like GCF, write down 1 7. But then I'm left over with a 2 and a 3, and because we're doing multiples, I need to use those to find the least common multiple. So I need to do 7, they both share that, times 2 times 3. 2 times 3 is 6. 7 times 6 is 42. So 42 is our least common multiple. Let's take a look over here. Let's do some examples here. So I've got 2 and 6. 2 is prime. 6 is 2 times 3. So I'd look and I'd say, okay, I've got 1, 2. And then I have to write down all the other numbers, which is just 3. So the least common multiple of 2 and 6 is 6. Okay, let's try 4, 5, and 10. Ooh, 4, we know is 2 times 2. 5 is prime. 10 is 2 times 5. Okay, now this is where it gets a little tricky. If they all share the number, you write one number down. If only 2 of them share the number, you write one number down. So like we've got a 5 and a 5, write a 5 down. We've got a 2 and a 2, write a 2 down. Now I'm going to go through again and write all the numbers that didn't match up. Okay, so just a 2 here. 5 times 2 is 10. 10 times 2 is 20. So our least common multiple of 4, 5, and 10 is 20. Okay. So let's say they all shared a 2. I would take 1 2 away from all 3 of our numbers there and write only 1 down below. But it also works if we only have 2 that share it. Okay, then we have 3, 5, 7. 3 is prime. They're all prime. So in order to find the LCM for 3, 5, and 7, I just have to multiply 3 times 5 times 7, which would be 35 times 3, which is 15, 105 for our LCM here. Okay, I'm going to do a real quick recap. Gray's common factor. So let's do 24 and 60. Prime factorize. I'm going to see 12 times 2, 6 times 2, 2, and 2 and 3. Okay, then 60, if I prime factorize that, let's do 3 times 30, 15 times 2, 15 is 3 times 5 times 2. Okay, what do they share? Remember for Gray's common factor, we were just saying what do they share? They both share 2. I'll write it up here, I guess. They both share 3. 2 2s, 3 5. Oh, well, our greatest common factor is 6 because they only share a 2 and a 3. Now the difference between, now we're going to do least common multiple. Let's just do the 3 one to make sure we know how to do trickier ones. So 9, if I prime factorize, I'd get 3 times 3. 12, if I prime factorize, I would get 3 times 4, which 4 can be broken down into 2 times 2 times 3. And 15 is 3 times 5. Okay, so let's go through. They all share a 3, so I write down 1 3. And that's all they share. Really? Okay, so I have to write down everything else now. A 3, a 2, a 2, and a 5. So I'm going to get a 10 here, a 6 here, and a 3 here. So 3 times 6 is 18 times 10. is going to be 180. Now, aren't you glad you didn't sit here and do all the multiples until 180? Yeah, that would be kind of a pain, so that's where prime factorization really helps out. All right, that's all I have for you for today. So please let me know if you have any questions, and we'll go from there. We'll get lots of practice in tomorrow. We'll see you later. Bye.